So, a lot of the science being done on the International Space Station designed to learn more about how the human body responds to extended periods of time in the weightless environment of space. The space station crew members themselves serving as those test subjects. One new experiment in this area, which is actually sponsored by the Canadian Space Agency, recently got underway, and it's called the Marrow study, which is actually looking at bone marrow in these astronauts. Recently, my colleague Brandi Dean spoke with the experiment's principal investigator, Dr. Guy Trudel, a professor of medicine, surgery, and biochemistry at the University of Ottawa, and also with one of his co-investigators, Dr. Odette Laneuville of the University of Ottawa, and asked what they suspect is happening to the bone marrow of astronauts during long-duration missions in space.
We're a group of scientists at the Bone and Joint Research Lab, and we're focusing our research on the biology of rehabilitation. So when decreased physical forces are acting on the bone, as you described, there are changes on the bone itself, on the bone structure. But we were interested in what's happening with the other role of the bone as an organ, and that's really the role of the bone marrow inside the bone to form all the blood elements, the red blood cells, the white blood cells, and the platelets. So in our experiments related to immobility, removing the physical forces on the bone, we noticed spectacular changes in the bone marrow in some models, in that the bone marrow shifted from being full of cells producing the red blood cells and the white blood cells to a bone marrow more filled with fat cells, so a fat transformation of the bone marrow.
Okay, so if fat cells reduce blood cell population in bone marrow, what happens to the astronaut?
So if that process is led to its worst case scenario, that is a bone marrow failure, then you are unable to mount a response to produce the blood cells that you need for survival, basically. So bone is a rigid structure. So if you have invasion of one of its components, it's at the expense of the other component. So what would be examples of symptoms happening from a bone marrow failure? So basically, the lack of production of your red blood cells will lead to anemia. So a person who is anemic will be weaker, will have less resistance, less force, less endurance, which could compromise a mission. Dysfunctioning white blood cells or low number of white blood cells will make you more susceptible to infections or autoimmune diseases. The last function of the bone marrow is the production of platelets, and these are responsible to stop the bleed and to create a blood clot. So the changes that we've measured in the models and in bedridden patients are showing some smaller changes in fat accumulation. But if that were to be extrapolated to a longer mission in microgravity, this could lead to a bone marrow failure.
I see, okay. Well, so how does your investigation, the Marrow investigation, how does it look at that in astronauts in particular?
So the protocol we've developed is to gather some biological samples from the astronauts pre-flight, during flight, and after flight. And the protocols and methods that we developed was in collaboration with the Canadian Space Agency in Canada. And through a team effort, we were able to design some sampling methods that will allow us to estimate or to measure how much fat is in the marrow. And that will be using magnetic resonance imaging and coupled to spectroscopy. And also to look at the blood itself through samples of blood collected over time. So the sampling for alveolar air or breath will be pre-flight, during flight, and post-flight. So for this, we had to design a contraption that we use for collecting the alveolar air and not the air that is present in the airways. And so it's a temporal study. We will be able to estimate and measure the impact of microgravity exposure on the content, on the fat content of the marrow. I think what is key or what is of high interest for our team is the post-flight period and rehab. How does the body and the marrow return to a normal state after flight? So we will monitor those participants, those astronauts, over an extensive, over a year post-flight, and we are very thankful that for those who already have agreed to participate and those who will in future participate in Marrow while on board at the ISS.
How do you expect that this experiment is going to help us as we're going forward in future exploration?
As you alluded to earlier, this will have implications for astronauts on long-duration flights and upon their return. For example, we will evaluate if the phenomenon happens and how it evolves over time. It will allow to develop countermeasures. What could prevent this fat accumulation in the bone marrow? How fast does it progress? And when does it start to affect the red and white blood cell production? Countermeasures may be brought on board long-duration missions, such as the duration to Mars. That can be physical countermeasure, could be pharmacological countermeasures as well.
And I know you also mentioned that you were working with bed rest patients as well. So are there implications to this that could help them in the future, or any of us here on Earth?
Brandi, you're talking to a rehabilitation physician, so this is really the angle that we have taken to approach this topic. When you receive in a rehabilitation center patients who have been in hospital for a long time, who are deconditioned, and you need to bring them back to their previous level of health and of function, then you have to look at the restoration of every system. Of those, there is the bone system, muscle system, balance. So when an astronaut comes back from a long-term mission, he presents many of the same characteristics as a rehab patient on Earth who has been immobile for a long period of time. Now, specifically for Marrow, many of those patients who have limited mobility, who have been in bed for a long time, or even in our Western societies, the sedentary lifestyle, or the change in demographics where people move less and less, we do notice higher proportion of anemia, more susceptibility to infection. So our findings could apply to the large number on Earth.
That's definitely good news for us and the astronauts then. We really appreciate you talking with us. Again, this was Dr. Guy Trudel and Dr. Odette Laneuville from the University of Ottawa, talking to us about their work with the Marrow investigations. Thanks so much.
Pleasure.
Our pleasure.